Welcome to RN tutorials on thermal engineering. And in this video lecture, I am going to explain about the concept of continuum, which we need to discuss in physical science, mainly in thermal engineering. We discuss about the concept of continuum to know the knowledge of macroscopic point of view that we generally select to study the behavior of the object when it undergoes a thermodynamic process. Okay, so let us have a look over the concept of continuum. So first, the concept of continuum means by which what we can understand means here it is a phenomenon by which we can understand about macroscopic and microscopic point of view. That means here we can be able to differentiate in between macroscopic and microscopic point of view, and at the same time why we are selecting the macroscopic point of view in thermal engineering to study its behavior when it undergoes thermodynamic process here. Okay, so here I am telling you that in thermodynamics or thermal engineering we select the microscopic point of view to study the behavior, that means the variation of the properties when it undergoes a thermodynamic process. So why we are selecting macroscopic point of view, that we can understand by the concept of continuum. Not only the difference between macro and microscopic point of view, we understand why we are selecting the macroscopic point of view. So let us have one take one example. Assume one object, any object of arbitrary shape. So when you consider any object, here we can say that it is made up of discrete particles, small number of particles. Okay, when you take any object, that is made up of number of discrete particles or atoms. Okay, by the combination of number of atoms which are made by the molecules and that are made by the neutrons, protons and electrons, the object is made. So whatever the discrete particles you are considering here, okay, those are arranged together to form a solid body. Okay, when the combination of these atoms or particles are taking place, they are placed in a particular air space. Okay, when you are when they are arranging themselves in a space, certain air gap will be taking place in between each adjacent particles here. Okay, here we can say one more statement. According to the arrangement of these atoms or any particles by which a solid object is forming, means here one statement is, if the particle or atom is large enough as compared to the air space between adjacent particles or atom, then the property of the system is the average of properties of the individual particles. Okay, here we are saying if the particle is large enough as compared to the air gap is taking place in between any two or more than two adjacent particles here. Okay, in that condition we can say that the property of the entire system can be the average of properties of individual particles here. Okay, so whatever the property of the object we are considering, just like the volume, density, specific weight, and specific volume, so all these properties can be the properties of all, average of properties of all these discrete particles. Okay, so by this we can say that again, uh, in this condition we can consider the object is continuous and homogeneous. Okay, whenever you are able to consider the property of the system as the average of properties of the individual particles, in that condition we can say that object is continuous and homogeneous. Okay, here when it should be continuous and homogeneous means here when the air gap is smaller as compared to the size of the particle, in that condition only we can consider it is continuous and homogeneous. Okay, so by this entire phenomena we are considering is known as concept of continuum here. Okay, so this entire phenomena, how we are considering the object as a combination of number of discrete particles, those are small particles or atoms, and if the size of those particles are large enough as compared to the air gap is taking place in the space, then the property of the entire system can be the average of properties of individual particles. Okay, in that condition only we can say that object is continuous and homogeneous. Okay, so whatever the total conclusion we are going for, that the object is continuous homogeneous, so this entire phenomena we consider it as a concept of continuum. Okay, that means the concept of continuum is related to the macroscopic point of view. Macro means we consider the large enough particles by which we can easily analyze the behavior of the object when it undergoes any process, just like a thermodynamic process here. Okay, so remember the macroscopic point of view means that is related to the large particles. Okay, large enough particles at which we can easily analyze the behavior of the object in the form of variation of the properties to when it undergoes in a thermodynamic process here. Okay, then what happens when the particle size is going on decreases? So next we go for another case. Take the same objective or any other objective. If the particle size is decreasing, okay, if the particle size is going on decreases, what happens here? When the particle, if the particles or atoms goes on decreasing, then the particle or atoms becomes unstable. Okay, here the particle size is not large enough as compared to the air gap is taking place where in they are spaced to form object. So in that condition, the particles becomes unstable. So due to this, what happens again? It means the properties of the particles or atoms become discontinuous and the object becomes non-homogeneous. Okay, that means when you are considering the small particles, so in that condition, we we will not be able to analyze the variation of the properties of the system if the particles are very small. That means when they are not large enough to analyze the behavior of the object, automatically that object becomes discontinuous and it becomes non-homogeneous. Okay, that is the difference between the large sized particles and small sized particle, just like in the form of atoms, or we can assume when you consider the molecular level. So this variation we are giving when you consider the process at the molecular level. So molecular means those are very small particles as compared to the atoms. Okay, so in that case the variation of those properties we cannot easily find out. Okay, more complexity takes place. In that condition more care we need to take, and at that condition we will be unable to find the values of the properties. Okay, so that's why we select the large enough particles to study the behavior. Okay, so by this entire thing we can say that uh, we by entire thing we can analyze this concept of continuum in a proper way, that with the help of the graph also we can understand, sorry, with the help of graph also we can understand this concept of continuum. Why you are considering the large particles than the smaller particles means here, if you take a graph in between density and the volume here. Okay, so up to particular limit, the volume, that is the property, when the volume is decreasing or increasing, when the volume is decreasing, the density, which is the property of the object, may varies continuously in a linear direction up to particular level. Okay, now so when exceeds a particular level, that means when it becomes more less, that means yeah, the size is decreasing as small as possible. So in that condition, after a particular stage, the property varies randomly. Okay, in which direction it may be varying, we cannot understand. Okay, now in this condition, we will be unable to find out the behavior of the object. We will be unable to analyze the behavior of the object. It means we'll be unable to find out the property of the object here. Okay, so that is the condition here. We select the macroscopic point of view. Okay, so if the particles size goes on decreases, it loses the control on itself. Okay, so in that condition the process becomes complex to analyze its behavior by finding the values of its properties. Okay, so in that condition the object becomes discontinuous. Okay, that's why the properties varying randomly here. Okay, and the object becomes non-homogeneous. Okay, so that is the difference when you consider the large particles, when you consider the smaller sized particles here. Okay, so this concept we are understanding by the concept of continuum only. Okay, now so finally you can understand why you are going for macro and why you are not going for a microscopic point of view. This microscopic point of view can be also considered in some cases, but in that case where the more care is required, in that cases we go for selection of the microscopic point of view. But for our thermal engineering concept, we need only macroscopic level by which we can easily analyze the behavior of the object by finding the properties of the object. So next we go for the topic macroscopic and a microscopic point of view. Okay, whatever the analysis we done for the concept of continuum, we can easily give certain statements for the macroscopic point of view and microscopic point of view. So what are the statements? First statement we can give for macroscopic. In this point of view, we don't consider the events which occur at molecular level. Okay, so that means we do not study the behavior of the object at molecular level. Why? Because it is a complex process, and at the same time it means we consider the object with large enough particles or atoms. Okay, we are not considering the molecular level, means we go for discrete particles just like in the form of atoms. And next in this process what we can easily do means we can easily study the behavior of the object by analyzing the properties at large atom level which can be continuous. Okay, because of continuity and the homogeneity of the object, we can easily analyze the behavior of the object by finding the various properties of the macroscopic point of view. That means in macroscopic point of view we can easily find out the properties of the object when it undergoes a particular thermodynamic process. And similarly, next we go from a microscopic. Microscopic means completely opposite to the macro. So in this point of view, we consider the events which occur at the molecular level, that is very small particles, okay, for which we need to find out the behavior of the object by finding the properties of those individual molecules. Okay, so in that condition, what happens here? Uh, Here means what is the next statement I have given? It means we need to consider the properties variation at molecular level. Okay, and next what is the last statement? By this it becomes hard to study the behavior of the object by analyzing the properties at molecular level which are discontinuous here. Okay, so at molecular level the process of finding the properties becomes very complex. So in that condition we can consider the object as discontinuous and non-homogeneous when you select the microscopic point of view. So that's why we will be unable to analyze the behavior of the object when it undergoes a thermodynamic process. Okay, that's why we select the macroscopic point of view by which we can easily take the property as the average of individual particles which are large enough to analyze or to observe the behavior of the object when it undergoes a thermodynamic process. Okay, that is about microscopic and macroscopic point of view, and at the same time concept of continuum. Okay, so I hope you understand about the concept of continuum. If you still have any doubts, please feel free to give a comment to my video, and please subscribe to my channel and share my video with your friends, and thanks for watching my video. Thank you all.